Hello, my name is Halvor and I'm going to show what I've been working on for a master thesis, which is an instrument. And I'm gonna explain how it works, and I'm gonna give a demo showing a few of the parameters and behaviors I have implemented for the system. So this system is based on swarm intelligence, and specifically it uses an algorithm that is inspired by how bees move to find the warmest spot. And how it works is that you have lots of agents that can move between various pitches, and the more agents that are on the pitch, the louder that pitch gets. And so the agents move around by that they look around and see which note has the most agents, and then they go towards that note. You're also able to manipulate all these agents a bit, because when you play a key, that will drag the agents toward that note you're playing. This is basically how bees move as well, in that they gather up at the warmest spot and stay longer when it's warm. So now I'm going to give a live demo. So this is how the system sounds just by itself with the default parameters. However, you are able to manipulate parameters I have with these knobs that I have put here. So I'm going to give a little demonstration of what each of the knobs do. So the first parameter is this note length, which basically determines how long the agents will stay at one spot. So I can turn it up, and then you have the agents staying on the same place for much longer. Or I can turn it down, and then you have these agents instead moving around very quickly and being very active in how they move around. The next parameter to demonstrate is the keyboard impact, which is basically how much impact does the keyboard have when you play on it. So if I set it down to 0, I have no impact because the agents ignore the keyboard completely. While if I set it up, the agents will be much more influenced by what's being played on the keyboard. You can see here that the note changes which note is being played. The system has most impact from the keyboard when you're holding notes down to change how the agents go somewhere. So the next parameter to demonstrate is the update time, which is how quickly the system updates. So you can set this down as low as possible, which sounds like this. In this case, of course, there's very much just noise, and it moves around basically as fast as the system is able to process the commands being sent to it. Alternatively, you can increase the update time to instead be 1 second. And then you get this kind of behavior where there's like every second there's a very small change happening. The next parameter is the number of agents that are involved in the swarm. By default it's 2000, but you can either set it up to 10,000 or you can set it down to have only 3 agents. Get this kind of behavior here, which tends to be quite harmonic, just because when you only have 3 notes, you tend to find some chord, however weird, that kind of like works with them. The next one is very simple, but also is kind of interesting, which is just the volume of the swarm, and you can set it down to 0, which produces no sound naturally. or you can set it up to its maximum. And this creates a very interesting sound because the audio is generated with sine waves, and when you set the audio out so high, the sine waves are basically clipped, so you get this very raw noise, almost kind of industrial in a way. The next is the same, but instead of being the swarm playing, it's just the volume from the keyboard. So right now it's 0. So if I play, you hear nothing from the directly. But if I set it up, you can now hear that you can hear something playing. And if I set it up to the maximum volume, you get the same thing again with this very almost like L guitar kind of sound that's coming out of it. Next is the agent move range, and this one basically determines how far the agents are allowed to go. When the agents move, you move a random distance between 0 and the maximum range they're allowed to move. And this can, when you have a very low range, it sounds like this, where you have it only moves one note at a time. While if you set it up to be the maximum, which is the entire keyboard range, it spreads out much more, and it's kind of because the agents are just randomly distributed between all the notes in every direction. Last, you have something that's somewhat related to the agent move range, but it's instead the agent look range, which determines how many notes to each side the agent is able to look when they try to find the best note to go for, the note with the most agents. The effect of this is that when you have it low, you get this kind of behavior where there are almost every other note is being played in some way. Or you can set it up to its maximum, where you essentially only get one max note in the entire system, since all the notes are dragged towards it. In addition to these parameters, I've also made some predefined behavior, which is more a way to ease into seeing what the system can do and just get some idea of the extremes for the system. The first one is just a keyboard where you can play whatever you want. Next is this behavior right here, which I have dubbed the island behavior, because in the visualization it kind of looks like an island with the sea, with the sea between, where there are no agents. Next we have what I've dubbed the even or every other note behavior, which looks like this, which is what you saw with the low note range earlier, and it has the name because it's every other note that tends to be high. This behavior tends to be, somewhat harmonic in a way, just because every other note fits well with the traditional idea of a scale, though there's also a bunch of devil's interval in there. Next we have the few agents behavior, which looks like this, which is very simply, you have very few agents, you only have 3 agents. And this is a very different autoscape, because there's only 3 notes being played, as opposed to in the main system with many agents, every note is being played in some way, though it might be very faint. But here you have only 3 notes that were being played, and it's pretty loud. It's very harmonic in a way, because with 3 notes it tends to fit some kind of chord. Next is the behavior where the agents are only allowed to move one space at a time, and they have to always move, they can't stay at the same spot, and that sounds like this. This one has also been dubbed the Bowser's Castle or chase scene from 80s sci-fi. Next is one of the more interactive behaviors, where you interact directly with the swarm, which I've just called the swarm instrument. That's because you're able to play the swarm by yourself, so you can it will go to, it's basically going to the note you are touching. Yeah, and now we have our tool for the second to last behavior, which sounds like this. I don't think words necessarily describe this. This is just a very chaotic behavior to demonstrate what that can sound like and demonstrate some of the extremes of the system. And lastly, we have the behavior that's probably most alike to the bees the system was inspired by. And that one sounds like this. yeah, that's the system. Hope it was interesting. If you enjoyed the video, like and subscribe.
Nice.